Hello everyone, welcome back to ptet.chemistry channel. So in this tutorial video, we'll start off a new topic. This is called chemical reactions. In essence, what we'll be talking about is redox reaction, which is actually one type of chemical reactions. So this is part of the 5070, the single science called the pure science chemistry. It's also similar to any 14 to 16 years old pure chemistry curriculum all around the world, which includes the IGCSE international curriculum as well as the GCSE curriculum based in the UK. So in this first part, identifying physical and chemical changes. So the syllabus says students, 14 to 16 years old candidates or students should be able to identify physical and chemical changes. So a lot of reactions, we can classify them into whether they are physical change or whether they are chemical changes. Chemical changes basically is what we are dealing about when we talk about chemistry, is to do with chemical reactions. So there is something about their structure, something about their bonding that has changed going from one form to another. So that's what I meant by usually that is forming something new. Physical changes, however, are not chemical changes. Therefore, there is no change in the chemical composition. There's no change in the chemical identities. It basically is like change of physical state, such as from solid to liquid. That is like melting, or you can talk about boiling, condensation, freezing, sublimation, or deposition. So just a very simple table to describe whether what are the differences between physical change and chemical change. There isn't really a need to memorize all of these, but it's really important that as someone who is studying chemistry, as a chemistry student, as a chemist, you'll be able to tell people what is the difference between the physical change and a chemical change. Most of the time, we'll be talking about chemical change because we're talking about chemical reactions, but you must also know what physical change means because, well, that's how you know that they are not chemical change to begin with. Reversible reaction is one type of reactions where you can go both way. So can you go from one form to another and go back again? So that one is reversible because things like change of state. So we know that we can change from solid to liquid. We can go from liquid back to solid or liquid to gas and then gas back to liquid. Chemical change is often not reversible because you're already changing into a new composition, and therefore to change back you have to change the composition all over again. In terms of identity, you don't form new substances, there's no change in chemical compositions, but you do actually form one or more new substances. As you know, you write chemical equations, you write balanced chemical equations because whatever you do in chemistry, every single equations that you write must be balanced. Okay, chemical properties, so there's no change in the chemical properties because this is just physical change. There's no change in the chemical composition at all, no change in structure or the bonding. However, when it's a chemical change, you're changing the entire chemical composition. More importantly are the specific examples because you really must be able to identify all of these as physical change. So as I mentioned, change of states of matter is one thing, and then another thing is when you form a mixture. When you form a mixture, so whether it's an element and element, such as when you mix nitrogen and O2 and other gases, that is the trying to recreate I guess you have like 79% or 78% nitrogen and then 21% oxygen and other gases that's present in air. So trying to combine different elements together, mixing them together but not reacting them together. So there's just physical change because it involves a mixture of these combinations. All of these reactions on the right hand side, they are what you call chemical change. We talk about a lot of these reactions in the last couple of topics when we did what did we do? We did more calculations, we did chemical structure and bonding. So you know about acid plus base reactions. So acid plus base, acid plus alkali or a base, that will give you neutralization reactions where H plus reacting with OH minus giving you water. Then the metal plus water reaction give you the metal hydroxide and hydrogen gas. Metal plus acid give you metal salt and also hydrogen gas. Metal carbonate plus acid give you carbon dioxide, a salt as well as water. Ammonium salt, the test for ammonium ion is when it reacts with sodium hydroxide and then you will get a gas. That is because ammonium salt plus sodium hydroxide. As you have seen, they are a lot of times when we did the qualitative analysis topic, it will give you NH3 plus H2O. So this one loses the H plus, is acting as an acid, because acid donates the H plus, or it loses the H plus, and then this one gains the H plus, and that's what gives you the water. So you're supposed to test for the ammonia gas, which will turn red litmus paper blue. So the gas displays, the gas produces ammonia. However, the ion present is NH4 plus. Thermal decompositions. Decomposition means they break down into different stuff. So one substance could break down into two things or three things. Thermal there refers to heat, so you're decomposing under heat. So for example, it's like calcium carbonate. You will learn more about this as a group 2 carbonate. A group 2 carbonate, calcium 2 plus CO3 2 minus. This is delta. Delta refers to heat, so delta, that little triangle there, refers to heat, and you will get calcium oxide plus carbon dioxide gas. As a result of this gas being given off, you don't see bubbles because there is no solution at all. You do not see bubbles, no effervescence, no bubbles, because there is no solution. Okay, and you cannot see a colorless gas, so you need to test for the gas. As you know from qualitative analysis and also experimental technique, you can collect the gas by displacement over water, so downward displacement, or you can collect it in a gas syringe. You can bubble the gas through lime water, and then what is the test? It will bubble through lime water, and then what is the result? It will turn lime water milky or cloudy. And then what is the gas? All right, identity. Next up, so color changes, like all those precipitation reactions, when we react metal cations with sodium hydroxide or a little bit of ammonia, both of which provide you the alkaline or the basic environment to precipitate out the metal hydroxides. Last but not least, electrolysis. That's actually our next topic after we have covered redox, because you really need a good foundation of year 9 redox chemistry in order to do this very difficult topic at the beginning of your year 10 very, very soon. So that's it really on physical and chemical changes. The next part of these lecture tutorials, in fact the rest of this topic, is basically on this idea called redox reactions. So it's quite a fairly straightforward topic if you know what you're talking about, but there are very, very important details that you need to uncover first. So in the syllabus, it says candidates, meaning you guys as students, you gotta use a Roman numeral. So Roman numeral, just like for your group number. So you gotta know this is 1, this is 2, this is 3, 4, 5, 6, 7, and so on and so on. So there's just Roman numeral, and there's the indication of the oxidation number of an element. This is in the name, so when you're writing out in name in words, okay. However, when you're writing down the oxidation number, you write like +1, +2, +3, and so on. This is in number. This is not in words, okay? It could also be -1, -2, -3, and so on and so forth. If you're writing down as number, it could be these or these. It could also be 0 as well, as you will learn more about this when we start to talk about oxidation number. So that is just 0 there, okay? So what else can I tell you? Well, define redox reactions as having simultaneous. Simultaneous means happening at the same time. Simultaneous equations in mathematics, so you got two equations you gotta solve, all right? Simultaneous means at the same time. So in the same reactions, you get simultaneous at the same time. You get simultaneous reduction and oxidation. This is the first time you heard of this word called reduction and oxidation. And guess what? So redox is actually short for reduction and then oxidation. However, the way you pronounce it is not red ox like this, so you call it red ox because reduction and oxidation, but the way you pronounce it, because in English you need to pronounce it properly, you pronounce it as redox, okay? Even though it is short for reduction, red, and then ox, but you pronounce it as redox instead of red ox. You pronounce it as redox reaction, okay? So what is oxidation number that they are talking about here? This is just a very direct, very simple definition. However, just like with everything in chemistry, if you don't know definition, you can't move forward. So I'm just defining it. Oxidation number is just the charge that an atom will have if it forms an ion. That is not saying that every atom will form an ion, but in the formula given, if that atom forms an ion, what is the charge that it will carry? As a result of it, as we know, metals like to lose electron. If metals like to lose electron, when you lose electrons, you become positively charged. When you become positively charged, you will have positive oxidation number. That's very, very important to remember. Non-metals, on the other hand, non-metals found on the right-hand side of the periodic table, so the right side of the periodic table, they like to gain electrons in order to complete the outer shell configuration, in order to achieve the noble gas fully filled outer shell electronic configurations. As a result of you gaining electrons, electrons are negatively charged, and if they are negatively charged, then nonmetals like to have negative oxidation number because they are more likely to form ions. Therefore, that atom will have a negative oxidation number as a result of it. This is just a table to summarize what I've talked about. The metals are found on the left-hand side of the periodic table. So the left side of the periodic table, they like to lose electrons. They tend to have, meaning they are more likely to have positive oxidation number. They can have other oxidation number. So things like transition metals. So we haven't touched upon it yet, but you have seen already in your qualitative analysis topic, like you can have iron 2 plus, iron 3 plus. The oxidation number of these things refer to the charges there. So the oxidation number there is +2, the oxidation number there is +3. So transition metals can have different oxidation number because they exist as more than one type of ions, because they don't really just follow the simple rule of the normal main group metals. Things like group 1 will form a +1 metal ions, group 2 will form a +2 metal ions, but transition metals, they can have ions of different oxidation state, and you know how to test for these using sodium hydroxide and getting different observations very, very clearly. Nonmetals like to gain electrons, therefore mostly negative oxidation number. However, that's not saying that every single time you have nonmetals, you will have negative oxidation number, because there's just a generalization. That means that when you have a nonmetal which are bonded to oxygen and fluorine, that is when you can have positive oxidation number, and this is very true when we have like a nonmetal oxide. Non-metal oxide means we have a compound containing the non-metal and bonded to oxygen. If that non-metal is bonded to oxygen, that non-metal will have a positive oxidation number, because the oxygen is always the one that really want to be negative oxidation number. So the oxygen is going to be -2. That means the oxidation number of oxygen is -2. Instead of writing down in words like this, we just write O, which is the symbol for oxygen, bracket -2. It means the oxidation number of oxygen is -2, because oxygen really wants to gain 2 electrons to complete its outer shell. As I mentioned earlier, also in the syllabus, Roman numerals represent oxidation number. You can write the formula KMnO4. As you know, the ions are represented by K+, a group 1 metal ion, MnO4-. MnO4- is what you call manganese 7. In your year 9 earlier in the year, there was a table of ions. I did tell you that table of ions will never ever be given in exam except for practical. Okay, but you in your theory paper, you will not have access to those. Therefore, you must be able to name it. Manganate, that means a compound containing oxygen. This compound is a metal, so it's a metal with oxygen, and it's VII. This refers to 7 because the oxidation state of the manganese is +7 in MnO4-. By writing like this, Mn bracket +7, so this means the oxidation number of the manganese, which is the metal, the transition metal, Mn, is +7 in this KMnO4. Alright, I'll show you later on when we come across oxidation number more and more why exactly this is +7. You're supposed to know how to calculate it later on. Lead 2 sulfide is PBS. So far what you know from the name is lead-2. Lead-2 means it's Pb2 plus, so it's got a metal cation. It's also a non-metal anion. S2 minus because it's a group 6 anions, group 6 non-metal, gain 2 electrons to complete the outer shell. So Pb is in group 4. You expect group 4 to be like, semi-metal. But as you go down the group, we know that lead and tin, they are metals, okay? You use lead in pipes previously. That's why you get the word plumber, because the original name of Pb is plumbum. There's the Latin name, and plumbum, that's how you get plumber, person who repair pipes. But of course, we don't use lead in our water pipes anymore because they are poisonous, obviously. Okay, so Pb2 plus S2 minus, 2 is to 2 plus 2 minus 2. You know the charge will need to be cancelled out when you balance out equation. That's why you get 1 Pb2 plus and 1 S2 minus. The oxidation number of lead in lead-2 is plus 2. The oxidation number of sulfur in S2 minus or in PbS is minus 2. Okay. Just to finish up what I wanted to in this lecture tutorial. So these are specific definitions. It's not saying that all 4 definitions will need to be satisfied. It could be any one of these definitions that needs to be satisfied. It's very important that you're able to identify each and every one of these definitions. Okay, so this is oxidation, and this is reduction. You will see that they are total opposites. One is gaining, one is losing oxygen. One is losing electron, one is gaining electrons. One is increase in oxidation number, one is decrease in oxidation number. What is very important in this kind of definition is not to try and remember both of them, but to try and know one thing very, very correctly, and then the other one is the total opposite. Okay? So these are just very, very simple summary definitions. It's not going to be useful to you unless you know specifically. Okay? Just like metal, non-metal, cations, anions, things like those things tend to confuse you back then, and these are the kind of things that will keep on confusing people unless you know one storyline very, very clearly, and then the other storyline is the total opposite. Okay, if you try to master both of them by remembering both of them, you will confuse yourself. Therefore, get your story straight for one of them first. Oxidation. So oxidation is gaining oxygen atoms. Oxidation is also losing of hydrogen, but then this is not loss of hydrogen gas. It actually refers to loss of hydrogen atom. Okay, so they are not talking about losing the molecule. They are talking about losing atom. Okay, so not the molecule, but the atom. So not the diatomic molecule. So we are just counting atom. Have you gained oxygen atom? Have you lost hydrogen atom? And then there's an acronym, OIL-RIC. Oxidation is loss of electron. Oxidation is loss of electrons. And then reduction is gain of electrons. So there's OIL-RIC. Okay, it's quite a popular, what do they call it? I forgot what they call this kind of short form already. But basically you can remember it as OIL-RIC. Oxidation is loss of electron. So you're losing electrons, and this is reduction is gaining electron, OIL-RIC. And then last but not least is to do with oxidation number. Remember, oxidation number is just the charge that an atom would have if it forms an ion. So when you have an increase in oxidation number, because we are talking about chemical changes, we are talking about redox reaction, so you will get something oxidation number changing, and when the oxidation number increases, that thing has undergone oxidation. Just to summarize, reduction is the opposite, involve the opposite of it, so you lose oxygen, you gain hydrogen atom. OIL-RIC, reduction is gaining of electrons, and reduction is decreasing the oxidation number. I'll give you a very, very specific example for this thing. So think about sodium. Sodium is a group 1 metal. So when you have sodium, Na, sodium loses electron, it forms Na+. It loses electron. Sodium loses electron, it loses 1 electron to become Na+. The oxidation number of sodium in the element, because this is element, it is not bonded to anything, therefore it's not going to form any ion. The oxidation number of the atom in the element is always 0, as you will learn in the rules for oxidation number very soon. The oxidation number of the atom in the ion follows the charge of the ion is +1. This one has increased. This one has increased in oxidation number. Increase of the oxidation number means sodium has been oxidized. Whenever you have an increase in oxidation number, you also are accompanied by loss of electrons. If you look at in terms of electrons, the plus electron is on the right hand side, meaning the sodium has lost electron in order to form Na+. Therefore, the sodium has undergone oxidation, or the sodium has been oxidized. That is basically the idea of oxidation. Okay, I can show you an example with the non-metals, but we'll cover more of these in the later part of the lecture tutorials in the next part. Okay, I'll leave it there for this part of the tutorial, and I'll see you in the next lecture tutorial. Thank you for watching. Don't forget to click the button on the bottom right to subscribe to the channel, and share the channel widely with other people whom you think these tutorial videos might be useful for. And follow me at ptet.chemistry on Facebook, Instagram, Twitter, and Telegram. And thank you for watching again.